government will decide where to put money, process, and also any other kind of legislation. This is the European context. I take that as an example because it's very interesting. In fact, you start with regulatory frameworks. This is guidelines, which is not binding. You pass to regulations, European regulations and directive. This is voted by the European Parliament, and automatically they becomes European. And this is the documents that they bind the different components of the European Union. The directives has something very important, is set a specific date that they have to be implemented or transposed in the national legislations. When Europe implemented the LENI, they told to countries you have up to that date to validate and transpose this European directive to your own legislation. If countries they don't do that, they have some sanctions. For lighting products, you will see that you have very similar stuff here in India, especially for labels. Well, in fact, there is the story of European directs for lighting products. It starts rather early, 2009. We implement 3 directives that you can see here. 1 for tertiary lighting, buildings lighting, and 2 for residential lighting, the version 1, 2009, and its new version in 2012. And this is to design, this is to implement that we call eco-design, and also the famous CE label, European compliance, and inside eco-design, European Union set minimum energy performance standards. They set MEPs that they limit the penetration of low efficient products in the European markets in all countries. And from the other side, Europe implemented in 2010 the European energy marking. US had the equivalent of that we call Energy Star, that has been implemented before the European label. Europe follow after. And for that, you have here the European directive dated from 2012. All those directives, if you look the numbers here, you can find it for free in the European web page, and you can find even to all European languages. There is the famous eco-design directive. This eco-design directive is, it requires product marking based on their effectiveness. And not only marking, but is the marking is not enough high to comply with the text, those products, they cannot be sold in any European country. To calculate, same thing. Once again, we as engineers, we can be surprised that the calculation of power, of efficiency, or things like that, they don't rely anymore on standard scientific calculations, but you have some specialized definitions of power, of light flux, and things like that, because they take into account the different various cases that you can find in the market. And finally, you have to find a trade-off between the huge variety of products and the definitions. For example, the consumption of light sources that is declared by the manufacturers is given by the Annex 2 of Eco-Design. And you see, for example, this is the power maximum that the product can achieve. It is given here with this relation with C is a corrective coefficient that takes time, depends on the type of light source, and gives some bonus for very effective sources. And this is just to push the market towards to more efficient products because you give bonus. L here, phi, F, H, and R are different coefficients. The factor F, for example, is equal to 1 for lamps that they emit light in all space, and is equal to 0.85 for spots, lamps that they have directional light, because they assume to light up a simple place, not all the space. R factor here is linked to the color rendering index, and you see if the color rendering index is lower than 25, which is the case of sodium lamps, this is equal to 0.65, is very penalizing. And you have other definitions. Phi here is the flux, the number of lumens that the manufacturer declares. Say my lamp, 8 watt lamp, this is not 8 watt here, has a 100 watt, for example, 100 lumen flux. Okay, and here you have the tables in the annex that gives the values of C, L, and R for the different products. Once again, the idea here, because such curious definitions, which is political definitions, they are not engineering definitions, is just linked to the fact that we want to compare all the products with the same values. Okay, and this is not possible to do it due to the different technologies. Well, once you have that, you will use that information in order to label your products. You need to put labels. Labels, there are different kinds. You have brand labels. Okay, you look who produced my shirt. I have something on the top telling that this brand is, I don't know, Lacoste or something else. Then you have description labels. It tells you this one, you don't have to put it in a higher temperature than that in the laundry, because you will degrade it and things like that. And then you have quality labels. This is what is the more interesting for us. Brand and use information is important, but the quality is the most important stuff for people working with electrical appliance and of course with lighting. And we know today that consumers, even if they don't understand anything about the technology, they rely more and more on the labels. If a label indicates that the product is not very good, we know that people, they will refrain to buy that product. And you tell me why I will put a label in my product if it is bad? Because I am obliged by the law. If I didn't do that, my product is just banned immediately from the market. Two kinds of labels for any of those three that I told you is mandatory or volunteer. The energy label in lighting products in Europe and in India is mandatory. You cannot read off that label. Some other labels can be voluntary. You can add it or not. It's good for your product or not. And they can be certified by accredited laboratory, or can be just manufacturer swears, I don't know to who God, that my product is compliant. If it is not, you will have problems with the national authorities, with the market authorities. For Europe, the most important one, which is mandatory, is the European compliance. The CE market is defined by some text you can find here. And if you don't have that marking in your mobile phone, in the micro, even in some other kind of applications everywhere, you cannot sell the product legally to the European market. But it is declarative. The manufacturers say my product is compliant with a CE marking, and also there are some very funny people. This one is not exactly the same graphics. You see the CE graphics is standardized, is two O's. If you want, cut it in the middle. This one is China export. It's an official label recognized by the Chinese government. But, okay guys, my product is not compliant with Europe, but it's exported by China. It's not the same. And well, same thing here. For example, here you can buy products that they are labeled CE European compliance, and you can buy also Chinese products. In principle, in Europe, this is forbidden, but here you can find both. Be careful which one you are speaking for. Someone can tell you this product is certified for European Union and show you that label. See the difference in the graphic. Because Chinese, they are not allowed to use, of course, the real graphics. But this one is not illegal. Second label, I told you that yesterday, and today I will tell you a little more, is the ENEC, which is the European Electrical Standard Certification. This is a real high quality marking. Because to get this label, or ENEC Plus, which is the new version, you have to be able to certify that your product is compliant with a number of tests, and this certification can come only by certified labs. A certified lab is what? You can have a metrology certification laboratory in your company, but this laboratory is certified by an accredited body, and this accredited body is usually the National Metrology Lab. Here in India, you have a National Metrology Lab that can accredit, then certify laboratories for different kind of measures. Maybe if they don't have the possibility to certify for lighting, you have to go somewhere else. But you have a laboratory which is certified by an accredited body, which is a national and governmental body always. And this body is not alone in his space, but is co-accredited with other metrology labs. And this is finally, you have the World Metrology Standardization Association, who control all the accredited labs. Here is, okay, the issue. And when you do that, if you have a certified lab in your company, for example, to measure power, to measure flux, to measure color rendering and things like that, you have to do it following standards. We speak about that, using calibrated devices with certificate of calibration, recalibrate almost every year, at least one per year. The laboratory has to be certified ISO 9001 and has to have dedicated operators. Someone working in a certified laboratory cannot be a retailer the rest of the time to the store just nearby the industry, or occupy a second other position inside the industry. Equal all that constraints. Having a certified laboratory is extremely expensive. Make also your measurements from someone else is also extremely expensive. Well, the companies, they have to find a trade-off. How many products I have and I need to certify often. In that case, if it costs me more to have my own lab, I will go to ask the certification from someone else which is certified. If not, I will create my own lab. But in any case, if I have my own lab or if I go to a certified lab, the laboratory will put here his laboratory number. We know who made the certification, and as it costs a lot of money, and as that label is voluntary, if you put it, most probably is that your product is very good quality. Otherwise, you will not spend money to add a such label. Of course, you can do it fake, okay? But fake, as you know, who made the measurement, if you have any doubt, you call the lab and they told you, yes, I look that product or not. And then you are in trouble with, I don't know, here in India, who is checking the quality in the markets. You are usually in trouble with customs or with tax authorities. And in any country, customs and tax authorities, they are not always very friendly. Well, it's preferable to not put the label than to put something fake. The European energy label. This is an obligation for all electrical appliance, residential, at least home appliance or lighting. And this is the label. The label you will see evolves, and this is there is a reason behind. This is mandatory for all lighting products, but not only, it's also mandatory for furnace, for laundries, for everything that you have, any electric appliance, you have to have that label, and it is the same for all of them. And look here, you understand why it is important, because if you ask, 93% of the consumers said that they have seen the label, has to be visible always on the stuff, but also on the shelves. 79% know what is, and only 14% say we don't know what is. That is here a lot of information to people to understand, and 79% of European consumers say that they rely in the label. If you have two products, one C and one A, and if the products in A is a few percent more expensive than product C, they will go to buy product A, because they know that they will have some return on the initial investment on the energy savings. Okay? That means if you have products here and some other manufacturers are product theirs, means two things: or you as low quality manufacturer, you will stop selling products in Europe, you go to other countries, or you will fail, or you will make enough efforts to push the quality of your products in higher levels. And in all cases, energy gains increases, and the consumer is also a winner. There is the label. In fact, you have a scale. This is the new one, I will show you after, going from A to G. And this has to be visible always on the product, either on the package, but also in the shelf places that you sell the product, and has to be also always facing the buyer. You don't have to get the box and look where is the label. The label has to be put in such way to see it immediately. This is legal obligation. And you can have all the label, but if the product is very teeny and you don't have space, you can just replace with the letter. Okay? And you have something interesting here, a QR code. And if you scan that QR code, you can, as even general consumer, access the European database, April database, that you will have all the registration information, all the register information for the product. That is much more that you can find in the label. Just scan the code and you have all the information there. And for lighting product, it's obligation to say how many kilowatt hours you will consume if you use the product during 1,000 hours. Well, kilowatt hours, 4,000 hours, normally they are kilowatts. If you want, is power at the end, but we are speaking here how many kilowatt hour will pay 4,000 hours of use of your product. And from 2021, when we change the label, all products that they have that label, they have the obligation, the manufacturer has the obligation to go make the declaration in the April database. If they don't do the declaration, they cannot use the label. And if they cannot use the label, they cannot commercialize their products. This is the evolution of the energy label. You see, we start 1998, the original one, with a scale from A to G. Initially, you had to show how many lumens, how many watts, and how many hours is the lifespan of your product. In 2013, we changed it. We add above A, A+, and some case A+++. And we simplify that part. We add only kilowatt hours per 1,000 hours are now. And from 2021, and at least 2030, at 2030 we have to revise again the label. We squeeze again from A to G. This information is the same, and the QR code has been added, and also you see the top of the label has been changed a little bit, but nothing new there. How you calculate this class, energy class? Again, this kind of definitions, they are legal definition, not engineering definition. And you see in the previous version of the label, you had to calculate this energy efficiency index, AE, which is given by the rated power over a reference power. And this reference power for lighting has been defined that way based on how many lumens your lamp is producing. This is above 1,300 lumens. That is for lamps that was equivalent of more than 100 watt incandescent lamp. A 100 watt incandescent lamp is 1,200 to 1,300 lumens. For lamps with more light than that, you use this relation here, where phi is the flux, and for the others you use that one, and then from this value you have tables telling you that if you are between 0.17 and 0.24 for non-directional lamps, you are labeled 8, okay? And you decide which one is here. That was the old way, very complex. Today we change that when we change the label, and now we just use this calculation here. You say just if the lumen per watt, the standardized lumen per watt of my lamp, they are above 210 is A, not has. I don't know why my computer add H and S. I will delete it. And in fact, what is the normalized efficacy is the luminous efficacy in lumen per watt divided by a factor here that takes into account if the lamp sends the light in all directions, or if it is directional, or if it operates on mains or in DC. There are some corrective factors to compare similar things, and now you have here in the label, following that, from A to G, you have the supplier name, the model identifier, the consumption per 1,000 hours, and the famous QR code. Why we do that? First, we simplify the way of calculating the label. This is more realistic, but we took into account that the new lighting products, they are much more efficient than in 2013. And the idea was to discard A+, A++, A+++, and so on, you go where. But also, look here, products that with the old label has been defined as A++, with the new label was ranked D or E. Products of A+ was ranked F or G, and products with less than that just banned. Well, this is that we pull we say push the market to higher values. We took into account the projections of what will be the efficacy of lighting in the next years, and we ban inefficient products, and we degrade all the very efficient products to low values, and this push the industry to go upper and develop more efficient products. When this happened in 2019, we had a zero product in all European market with labels A or B. Today, in Europe, the majority of lighting products are label B, and we start having some products with label A. That shows that industry push the quality and the energy efficiency of the product. This is the power of the labels. The labels is not only to protect the consumer, but it's also that we call a pull-push effect. They push the products to more efficient values and enhance the quality. Okay, and you have some blah blah here, but you understand that the objective was really to get more efficient products in the market. What is inside the April database? In fact, you have several information. I'm sorry, I don't have, I could get a box from a European lamp to show you. You just can scan the code and get all the information inside. This database is huge. All the electrical appliances since 2001 are inside, and they are 3 access levels. One is general consumer. You scan the code and you see what the manufacturer declared. The second is access for the manufacturer to make the declaration. It's free. They don't pay anything for that. There is a control, automatic, if it is coherent, and then the manufacturer gets the authorization to use the label. And there is a third level of access, which is reserved to authorities or different people that can have access. For example, me passing through the European Energy Agency, I can have access to that data, and serves for 2 things. One, to extract the data and show you all the 1,000 points that I showed you last time in order to make predictions, and also can serve to authorities that they are checking the quality of the products and the compliance. They can get one product, make a test, and if the product is not compliant with what is declared, in principle, we know today that when such kind of labels and registration is imposed, we know that immediately 5% of the manufacturers, they comply. 5% will never comply, and we have to find them and get them out, and the remaining will comply if they think that they have less than 10% of chance if they put non-compliant product to not be detected. This is some economics calculations. And finally, 95% of the manufacturers, they will comply under different things with a database. This is very funny because before starting to have the April database, Americans, they have the light fact database that was there since 10 years before April for lighting. But some countries in Europe, they had their own database. And the best example there is Denmark. Denmark is a small country. I don't remember how many million people is. It's very small. It's maybe the equivalent of a big Indian city. Okay, but in Denmark, people, they are very strict concerning regulations and things like that. They buy a lot of product passing through e-commerce, through their computers, and the Danish government decided to say, okay, for lighting, you have to declare your products inside our database. It's a declaration, but every year we take some products randomly and we make a test. And if I found a single product of your company that is not complying with what you said, then all your products, they are banned for 5 years from the database. And all European, or say 90% of Danish consumers, they look the database, and if they are not in the database, they will never buy. You don't have any interest to declare a product which is a fake declaration, because you take the risk to see all your products out from the Danish market. That was the idea, and Europe took a little bit that idea, and they created the April database. Well, today you can see that European labels, especially energy labels, they are recognized by many other countries. Everything green here, recognize labeling. Other countries, they have labels under development. India has their own labels, and in fact, you have a very few alignment with our label. But I will show you here some example of the equivalent of European labels. This is the American label. This is the Energy Star, and behind you have the Lighting Facts European program. And when you have this one, you have to comply with some regulations. And this is the label for lighting products that you will find in US. It contains the brightness, the lifespan, the wattage, the light appearance with the color temperature, and also the yearly estimate cost. You see, they have much more information that we have in Europe. And in fact, you can ask, is it really necessary to have all that information in the label? You need much more place. And if you need much more place, you need a larger box, which is not very good for the environment. And finally, European consumer can find all those information by just scanning the QR code. This is the Japanese top runner label. Japanese use stars, and you have some information here. Same thing, you see how many kilowatt hours you will use per year. In Europe, I remind you that it's a kilowatt hours per 1,000 hours of use. In fact, at home, the lamp that you keep on long time, you use it around 1,000 hours per year, which is almost the same thing. And then you have e-marks here, green or red, concerning the efficiency of the product. This is the Chinese one. Yes, China has also labels. If they want to comply with international markets and be able to sell their products, they have to prove that they have also their own labeling system. Same thing, you have a number of information, a QR code like in Europe, Australia, Korea, New Zealand. This is the Korea one. This is the Australia and New Zealand. Here, this is very funny because LED lighting products for the moment are not comply with minimum energy performance standards. That means even if the product has 0 stars, can be in the market, but you have to mark that you have 0 stars. This is yours, India. Normally you have to have it in the lighting products. Is that one? Is defined by the BE, Bureau of Energy Efficiency, and you are working same way like Australians or New Zealand, the number of stars. And you have to give also the brand, the model, which applicable standard has been used to test, what are the applicable conditions. You have here a unique code defining the product, is the equivalent of the QR code. Some different technical parameters depending on the appliance type, and technical details here. Here you have much more information than European label. The problem is, I don't know how many people here in India can recognize that label and can rely of what you buy. But more you have stars, here more efficient is your product. Most probably also more expensive is your product. And this is mandatory only for LEDs and tubular fluorescent lamps. It's not mandatory for CFLs. It's not mandatory if you still in your market you still have incandescent lamps or street lighting lamps. You don't have to have that label. This is another label, also Indian one, for self-ballasted LED tubes, again from BEE. And here is the way that explain you how to calculate the number of stars in the label. And as you see, that was in 2020. And also like Europe, you go from the old values to new one, and you see that here the efficacy in lumen per watt to get a single star up to 5 star, same thing, it increased. Once again, your government tried to push efficient products in the market. Look, for example, here 3 star was between 19 and 105. Here 9 star is from 105 to 120. You push regulation versus standards. The regulation have a legal value. The standards is not a legal text. When you have a standard, it is very well advised to be compliant with the standard, but you can read off the standard. But you take a very serious risk, because if there is any heavy problem, for example, you don't light up correctly and someone is killed due to that, if you go to a justice court, the justice court will use the standard and will ask you why you are not compliant with the standard. If an expert, a technical expert, is not able to justify to the court why the standard has not been used, you lose immediately the case. Okay? It's not advised to not follow standards, but standards are always voluntary. That you have, unless if they have been transposed in a legal texts, which is often the case in some countries. And in fact, why we need standards? Because we can serve security purpose, but also interchangeability and interoperability of the different products. If you buy an Osram lamp or a Philips lamp or a I don't know what lamp, if you put to your socket, it will work. The question is for how many times it works, how many energy will consume, but it will work because follows the same standards. And also can help to eliminate and prevent technical barriers to trade. Well, different kind of standards. You have norms or standards. They are documents that provide by consensus and approved by recognized body. When you are working in a standardized authorization committee, I'm part of some of those committees. You have around the table people from industry, people from academia, people from governments and things like that. And then you have to find always compromises. What industry want to sell and what me as academic people can say this is meaningless and what the industry, the government wants. Finally, you have to, for me to lower my exigence and industry higher the minimum requirements and things like that, and we arrive at the end in a compromise, and this explains why you have such Kabbalistic formulas to calculate different parameters that me as and you as scientists, you are looking and say why we use that one, because these reflect the compromise of all those people that are around the table. Some of those standards can be international. Usually the standards they are national, validated by the National Standardization Authority. For UBE, for example, for energy, some of them they are international, like ISO or IEC guides, and some also they are coming from international organizations, which is no more national bodies. The standard for lighting, the main standardizing bodies for lighting, there's few. The first one is the CIE, is the International Committee of Illumination, Commission Internationale de l'Éclairage, is in French. This is the original name of this committee. Has been established in 900. It's very old. Lighting is the first thing that has been standardized. Okay? It's a non-profit organization dedicated to international collaboration and exchange of information. Here, you cannot be member. Your country is member. India is member of CIE, and they pay money to CIE following the UN quotation of the country. This is to exchange information. It's member countries and different things, and recognized by ISO, the International Standardization Organism. This recognition by ISO means that CIE can produce standards. Then you have EEC, the International Electrotechnical Committee, that has been founded 6 years later, 1906, promotes international collaboration and things like that. IEC develop and publish international standards for all electrical, electronic, and related technologies, and of course including lighting. And EEC standards are based always on consensus. Their adoptions is always volunteer. Some example, the standards of CIE. They are mainly looks on the light and lighting, including the definitions, how the lumen is defined, what is glare. This is described by standard documents by norm emitted by CIE. They are not any organism discussing this kind of standard. They produce international accepted standard, but the standards is once again based on a global agreement. And also, for example, they give all the requirements for making reproducible photometric and colorimetric measurements. How to measure a flux, how to measure a color point, how to measure correlate color temperature. This is described by CIE norms. And also something very interesting with IEC also, they introduced the international lighting vocabulary, which is accessible through the web page. Today, when we speak about illuminance in English, illuminance is always flux over surface. When we speak about luminous efficacy, is flux over power. And the wording, it is defined by that. And as usually lighting is something that is very old, and we have in our countries different words, the international vocabulary is a decline to all language. If you want, for example, in France, we use the word irradiance, okay, for the equivalent of what in English I have to say radiative intensity. It's not the same. Well, there are different words in different countries, and this vocabulary tell you in France, in India, in China, to say illuminance, you have to use that word. And this allows to all people to understand themselves. This is an example test method standard from CIE. For example, how to measure this one test method for LED lamps, LED luminaires, and LED modules. How to calculate the flux, to measure the flux, the useful lumens, the central beam, and a number of elements. You have to use that standard in order to be able to measure those quantities to a standardized way. For example, tell you to measure the luminous flux of a lamp, LED lamp. You have to put it in an integrating sphere. In the center of the sphere has to be at least 10 times larger than the bigger dimension of the lamp, and the lamp has to be always oriented from top to bottom, towards downwards, because you have to control the flux. They tell you that the sphere has to be in a temperature control room at 20 degrees plus or minus 1 degree, that the wind speed around the lamp has to be controlled, the humidity has to be controlled. They give you the exact conditions, plus or minus, what is acceptable. If you don't respect that, you can make a measurement, but your measurement is not correct, and you will never be accredited or certified by an accreditation body. IEC produce standards for any kind of electrical appliance, but lighting products, they are concerned by the technical committee 34 that splits in 4 subcommittees, one for lamps, one for lamp holders and sockets, one for ballast drivers and different other devices for lamps, and one for lighting fixtures. And they produce a number of standards for all these devices. Then you have other standardization bodies, ISO, the International Standardization Organization, with the TC 274, looking on lighting and light. The North American Illuminating Engineering Society, IES, NEMA, North America Normalization Authority for different electrical products, NC, the American National Institute, IEEE. IEEE, for example, produce standards for lighting installation for flicker in lighting. ZAGA is an industrial organism, well, an organism, standardization organism made by industry. The idea here is to produce standards in order to say how you can connect the different modules, sensors, all together in the same device. And then you have different national organizations, AFNOR in France, with this label, DIN in Germany, BSI in England, this is Japan, Korea, Australia, and this is Indian Bureau of Standardization for different kind of products. That means you have a huge ecosystem of standardization organisms, and all those organisms, they have standards inside for lighting. Lighting today is the most standardized domain of technology worldwide, and is in one of the older standardized domain also. And then you have the European Commission of Standardization, CEN, same thing. They give you a number of standards, and they are interested on some health issues. Up to now, all the others was lighting, electromagnetic compatibility, quality of the technology, measurement. CEN give you standards about the incidence of light to your visual performance, and also to some health issues. Examples, this is the LM series standards that explain you how to measure again flux or things like that, similar to CIE. And here is just an overview of all that ecosystem. And all that ecosystem for the moment doesn't speak about how many light you need on your table. We will see that this afternoon. There are other standards we are speaking about that. And here you see, if you are looking for shapes, dimension of lighting products, this is EEC and ZAGA. If you look about safety requirements for lighting products, going from electrical parameters, mechanical, photobiological risk, flickering, then you have this kind of organism, IC, ISO, IEEE, IES, CIE. If you look about lighting product performance in different things, here you have the different organisms that they propose standards. If you looking about test methods, there are the organisms. If you look about design requirements and lighting applications, you have standards here. And if you look about lighting design methods here, and finally energy performance, you don't have any standardization organization here. This is the duty of the governments. The energy labels, they are not regulated by them. This is only governments, because this one is mandatory, or the remaining is volunteer. Yeah, that was the last one. Thank you. Well, I tried to find Indian standards about lighting. I could find some, but well, I'm not sure that I found the last versions, because seems to be very old or never been revised. I found some standards for street lighting and some standards for industrial premise lighting, but I don't find anything about offices, about things like that, which is very curious to me. Well, if one day you want to do something about lighting, don't forget to look what are your standards. Small problem, standard documents, they are not freeware. You cannot get it for free, you have to pay, and usually they are very expensive. To have a CIE standard, if I buy something like that, is for one standard it's about 500 euros. Well, because all the standardization organisms, they have income by the governments or their members, but this is not enough, and they need to sell the standards. The standards, unfortunately, they are not public documents. Regulations, directives, yes. Okay, thanks. See you at 2:30, is okay for you? We'll speak about how light up now.